Welcome to Structural Engineering Online. In this video lecture, we will learn how to calculate support reactions of a simply supported beam. Please subscribe to our channel if you have not yet subscribed, so that in future you will get the notifications of new video lectures. Thank you. In this question, we will calculate the support reactions of a simply supported beam, which is carrying moments at the supports. There is a UDL for 2 meter length and having the intensity of 2 kilonewton per meter, and there is a point load also. So first of all, we will show how many reactions are possible on this beam supports. So here we have hinge support at A. Hinge support carries two reactions, one horizontal, one vertical. So we mention here HAVA, and at B only one reaction, that is VB, that is vertical, because this is roller support. So A is hinge support and B is roller support. Hinge support carries two reactions and roller support one reaction. Fixed support carries three reactions. Okay, if you want to know more about the support reactions, you can see our lecture number 1 on support reactions of simply supported beam. So first of all, we have to apply our equations of static equilibrium to calculate the support reactions. First equation is sigma fx equal to 0. And what did it say? If there is any horizontal force, we will consider here. Now there is only one reaction which we have assumed, because initially we don't know the direction of the reactions for horizontal or vertical. We assume them in their positive sense, and this is our positive direction. Right hand for x is positive, upward for y is positive, and the moments anti-clockwise are positive. So these are the sign convention which we adopt for our calculation. So when we say that sigma fx equal to 0, that means algebraic sum of all the forces acting on this beam equal to 0. We have only this HA, and assumed direction was positive. Okay, so we say that there is no other force. So for equilibrium, this HA will be equal to 0. Then we apply the second equation, sigma Fy equal to 0, and this gives you in y direction there is VA, there is VB, there is UDL, and there is point load. So we write here plus VA because VA is acting upward, plus VB, that is also upward, and this 2 kilonewton per meter UDL. Now this UDL is acting for 2 meter, and the rate of this UDL or the intensity of UDL is 2 kilonewton per meter. That's why the total UDL will be 2 into 2, and that is acting downward. So the UDL is also acting downward. So minus 2 into 2. Then this point load is also acting downward, and that is minus 2. There is no other load applied in the vertical direction, so this whole thing equal to 0 to maintain the equilibrium in y direction. Now we take the moment of all the forces. So algebraic sum of all the moments about A, and then we look at these things. If you look at VA and HA, these are acting at point A, so they will not give you any moment. The moments you will get from this support moment, which is here, this will give you the moment 4 kilonewton meter, and if you look here, this will give you the moment which is anti-clockwise. So anti-clockwise moments we take as positive, so we can say okay, plus 4. Then we look at this 2 kilonewton per meter. Now when we take the moment of UDL, we consider its centroid to find the distance. So center of this UDL will be having this distance from A as 1 plus 1. So the load is, because it is giving you a clockwise rotation, this UDL. So this clockwise means negative. So minus 2 into 2 is the load, right? We multiply the rate of loading with the length of UDL, then multiplied by the distance of its center from the point of moment. So in this case, 1 plus 1. This is the distance of this center. Then moment of this 2 kilonewton load, and this is 2 into the distance, 1 plus 2 plus 1. So total distance is, so minus 2 into 4, right? And then our moment of this support reaction VB and this support moment, which is 3 kilonewton per meter, we have to consider. So this is clockwise. So clockwise moments we consider as negative. So we will take this as negative with minus 3. And for this moment of VB, because this VB will try to rotate, if I apply a force VB here and this is my point A, it will try to rotate in the anti-clockwise sense. So anti-clockwise we consider as positive. So plus VB into the distance from A. So 2 plus 1, 3, 3 plus 2, 5, 5 plus 1, 6. So VB into 6 equal to 0. And this is our sigma m equal to 0. Now from here we can calculate the value of VB. So here when we simplify, 6 VB will be equal to 3 plus 8 plus 8 and then minus 4. Okay, 3 plus 8 plus 8 minus 4. So these values we have transferred on the other side. So we get 6 VB equal to 16 plus 3, 19, 19 minus 4 equal to 15. So 6 VB is 15, therefore VB will be equal to 15 upon 6, right? So 6 VB is, we can check again, 4 into 2, 8, with minus sign it comes here, minus 3 comes on the other side, plus, then 2 into 2, 4, and that 4 is with multiplied with 2, so it is 8, that also with this, and plus 4 will come here with minus sign. So VB is 15 by 6. Now we can calculate the value of VA by substituting the value of VB in this equation. This is our equation which gives you the relationship between VA and VB. So when we substitute here the value of VB as 15 by 6, so it will be VA plus 15 by 6, we can say the value of VB 15 by 6, and then we have minus 4 minus 2 equal to 0, and from here we can get the value of VA, and that is 4 plus 2 minus 15 by 6, and that is nothing but 6 minus 15 by 6. So we get this value as 36 minus 15 upon 6. 6, which is 21 by 6. So VA is 21 by 6 and VB is 15 by 6. So this way we have got the values of these reactions of this simply supported beam when it is subjected to UDL, point load, and support moments at both the supports. And this is very common question which comes in the exams, and also when you are solving the problems of fixed ended beams, this type of situation comes. I hope this video lecture has helped you in your problem solving skills for support reactions of simply supported beam. If you like this video, please share it with your friends and also subscribe to our channel so that in future when we upload new video lectures you will get the notifications. Thank you very much.